My name is Alex, and today we are going to be taking a road down to Limits and Continuity 101. First of all, we have to find out what a limit is. A limit is a value, a wide value, that a function approaches but never indeed reaches. In order to understand if there's continuity and limits, we have to see a graph and see if the limits exist as x approaches a given x value. For example, in this given graph, we're going to be using x equals 1 as your limit, as limit of f of x as x approaches 1. First, we're going to find if the limit of the function exists as x approaches 1 from the left side. Then we will be finding the limit of f of x as x approaches 1 from the right side. As you can see in the graph, as x approaches 1 from the left side, your y value is 2. Therefore, your limit of f of x as x approaches 1 from the left is equal to 2. Now from the right side, as you approach 1, your y value is 2 again. Therefore, your limit of f of x as x approaches 1 exists. Number 2, we have to find if the function exists. We're going to be using f of 1. As we can see in the graph, 1 and 2 correspond to a given point on the graph. Therefore, the function at f of 1 equals 2. Therefore, since the limit of f of x as x approaches 1 equals to 2, and the function of 1 equals 2, we can determine that the limit does exist and there is continuity.
Hi, my name is Eric, and a graph cannot be continuous if the function has a cusp, a corner, vertical tangent, or jump discontinuity. As you can see in this graph, in order to find the limit, you have to lift the pin, which is jump discontinuity. So in this example, the limit does not exist.
Hello, my name is Jose Campos, and I'm going to teach you how to prove that a function exists. Okay, so we are given this right here, and we're supposed to prove that the function is continuous at x equals 0. And in order to do that, you're going to have to use the criteria for continuity. So first one, you're supposed to prove that the limit exists at 0 from both sides as it approaches 0. So first, we're going to use this function, limit of x approaches 0 from the left because it is less than. So 1 minus 2. And then you plug in your x value, which is 0. So this equals 1. And then as your limit approaches x from the right, we're going to use this function because x is greater than 0. So it's e which also equals 1. So we just proved that function exists at 1 with the first criteria, part 1. Now we have to do part 2, which is proving that the f of x exists. So since this is less than or equal to 0, we're going to use this to prove that the function exists. Equals 1. So it also equals 1, so therefore, since the limit of x approaching 0 equals 1, and the function, the f of 0 equals 1, the limit exists.